So this presentation is going to be relatively short and mainly just pictures. And I would like it to be as informal as possible. So if you have any questions or comments, just butt in or put up your hand, and so we can have more of a discussion than me just talking. So I love raptors. Birds of all kinds, really, but raptors in particular are I'm really fascinated with, and especially vultures. I've been working with vultures for the last 10 plus years. So the first part, I'm going to talk about the Egyptian vulture, which is somewhat common in Armenia, but rare around the world. And then we'll talk about some work that I just got back from today with long-legged buzzards. So I don't have much like science-y stuff about that other than some pictures of us catching birds. So that's what I'll talk about. But please, if you have any questions, just like let me know. So the Egyptian vulture, and have any of you guys seen this bird before? You know this bird? They're kind of ugly, but kind of cool looking. It is globally endangered, so all around the world it's considered an endangered species. In 2007, it went from being least concern, where people thought it was doing totally fine, and they uplisted it all the way up to endangered, because there's evidence that its populations have declined really all around the world. But we don't know a lot about why it's declining. So that's part of this project, is to try to figure out why are these birds declining and what might we be able to do to conserve them. It's a really cool bird because it uses tools. So it's one of the few birds that is known to use tools. In this case, it uses rocks and sticks to crack open ostrich eggs, which are too tough for it to break with its bill. So it does that in Africa. So this bird ranges across Europe and parts of Asia, the Middle East, and into Africa. And in Africa, it cracks open these ostrich eggs. It's also, in most parts of the world, it's a human commensal, meaning that it spends a lot of time in proximity with people. And a lot of raptors are the opposite. They hate people, they want to be as far away from people as possible. But the Egyptian vulture is kind of like unique in that way, where it tends to be around villages. It really likes ranching and farming, and actually it likes dumps a lot. It also has a really early history in human history. So these are some pictures from Egyptian times with a pharaoh with the Egyptian vulture head scarf. So this is about 5,000 BC. So early human history was tied with the Egyptian vultures, partly because they weren't afraid of people, and they lived in proximity to people. And a particularly fun fact about the Egyptian vulture is you notice it has a really yellow-orange face. And one of the ways scientists think it gets so orange is from eating poop. Because poop can have a lot of carotenoids, which is like the chemical that's in carrots, which makes them really orange. And this is interesting because the more, the oranger their face color is, the more sexually attractive they are thought to be. And so it's a weird sexual selection where they're showing each other that I have a super awesome immune system. I've eaten a ton of poop. My face is really orange, and so I'm sexy. Kind of unusual. So this is a picture from a nest of an Egyptian vulture in a cave near near Goris that I took last year, which is cool because it's Egyptian vulture nesting in a really old cave around Goris. But the general objectives are to learn about where these birds are nesting, where they're feeding, where are they dying, and maybe why they're dying, and where they're migrating. So this is a long distance migrate migrant bird. At first, we weren't sure where the birds in eastern Turkey or in Armenia were migrating to, so that was something that we were really curious about. And so in order to do that, we use satellite tracking. So you see this bird has this crazy looking device on its back, and that is a GPS unit. In this case, it weighs about 20 grams, so it's about this big, a little bit bigger than my thumb. And on the back here, it has a solar panel. And so as the bird's flying, the sun is charging the unit. It's connecting to a satellite, and then relaying that information in a few different ways. But I will get an email to say exactly where that bird has been, and we get a point about 1 point every hour. Some other units that we have, we actually get 1 point every minute. So we have really specific data about exactly, with really good resolution, where these birds are going. So that allows us to learn a lot about the whole life history of these birds. So after we catch the birds and we put these devices on the back, we let them go back into the wild. So here's a couple pictures of that. This is in eastern Turkey. This is Anush in Flores, releasing Egyptian Vulture. So these GPS units are less than 3% of the bird's body weight. So they're meant to be really small so that they won't affect or hurt or harm the bird. Okay? So we release the bird and then get data like this, which is pretty cool. So this is Mount Ararat. You guys recognize kind of from the weird Google Earth representation of it. So this is a bird that was returning from Africa and migrating into Armenia from Africa. And this is one of a few special transmitters that we have where we're getting a GPS point every minute. So we knew where this bird was every minute. And what's really cool about that is you can see when they're gaining altitude or when they're losing altitude. So we can kind of figure out how they're flying, how they're using different updrafts or mountains to gain lift, and lots of cool stuff like that. So some initial results from this project. This is a map of the Middle East and East Africa. These are all of the 16 birds that we have tagged, or all the purple points, and all those purple dots are points where the birds have been. So this is just kind of like a big overview. So we've tagged birds in 10 birds in Turkey, in eastern Turkey, so just about probably 50 kilometers from here, right over the border. 3 in Armenia last year, 2 in Ethiopia, so 2 in Ethiopia, and 1 bird in Djibouti. And you see the birds from Turkey and Armenia have all migrated into Ethiopia. 1 bird is as far south as central Kenya, which is pretty cool. We also tagged the 2 birds in Ethiopia, and one of those birds migrated all the way back, came to Armenia, and actually visited the same spot where we tagged the other 10 birds. So there's a lot of connection between the birds in East Africa and the birds in the Caucasus, which is interesting. We didn't know that. We didn't know where they were going to go. So all this was pretty exciting. All the previous tracking data from Egyptian vultures in Bulgaria and Greece showed the birds coming through Turkey, crossing over, a couple birds trying to make it across the Mediterranean, but they don't have that much success. And then they go into more like Central Africa. So this was like a totally new migration route that we didn't know about before, and it was pretty cool to find out. So we have about 500,000 GPS points now on these birds. There's like a ton of data. It crashes my computer when I try to work with it, but it's cool. We'll be able to answer a lot of cool questions. These birds have traveled through 20 different countries now, which makes conservation hard, right? So when you have a bird that's visiting 20 countries, including places like Iraq and Yemen and Somalia, places where conservation can be really challenging. So I think that's one of the difficulties with Egyptian vulture conservation. So we have to deal with like large swaths of the world. So these birds are incredible flyers. They're amazing at how efficient and how fast they can cover large distances. So we don't really think of Egyptian or like vultures in general as being like speedy flyers, but they cruise lots. They can cover a tremendous amount of ground. So we've had vultures cover more than 400 kilometers in a day, which is a lot. As fast as 110 kilometers per hour in sustained flight. And a lot of people, when I put that up, are like, excuse my language, but they're like, bullshit. That's not true. That cannot happen. But what's happening is, or what I think is happening, because I really think that this is like legitimate, is you'll notice that they use this like thermally, and they get up really high, up to as high as maybe like 25,000 feet. And then once they're up at that high elevation, they can go into kind of like a semi-tuck and start losing elevation really fast. So they can travel really fast when they're descending. And then they'll hit another thermal, gain elevation, and then cruise down again. So that's how they can go so fast. They travel about 8,000 kilometers during their migrations from the Caucasus region to East Africa. It's only about 4,000 kilometers if you drew a straight line, but they cover a lot more ground than that. And we have one bird that we tagged in eastern Turkey that holds the record for how much distance a single Egyptian vulture has covered in a year. So this bird we named Ardahan traveled over 50,000 kilometers in 1 year. So enough to go all the way around the world, like way more than that. So that's pretty cool. As for these are kind of funky maps that I just put together in the last half an hour, but these are the 3 birds that we tagged in chorus. And this is where they migrated, so if you guys are interested in that. So one bird migrated into the Ogaden region of Ethiopia. The transmitter stopped transmitting, unfortunately. I'm pretty confident it was just a technical failure. We actually had that happen in the same area with the same type of transmitter. And I think it's because that area is really remote, and they couldn't. These were using cellular technology, and they couldn't connect. Blah blah blah. But I don't think those birds died. I think there was a transmitter failure. But we had another bird that didn't go into the super remote area and stayed in like the central Rift Valley of Ethiopia, and spent the whole winter there. And then it migrated back, but upon its return migration, it went a totally different way. Through Egypt and the Sinai Peninsula, and then came back to Chorus. And so it's back hanging out at the dump in Chorus. So a big migration. So just quickly, I'm gonna quickly go through some of the sciencey stuff that I'm gonna do next with this data, other than just like, wow, that's cool. They fly really far. I don't have the final results of the more sciencey stuff yet, but I'll just explain really briefly what I'm going to do. So this is from the 3 birds in Armenia. When you have all these points, the first thing is to try to get an estimate of their home range, which just basically means where does this animal live? Where does it go? And so this is a representation of the home range for 3 different birds. You can't really see the one on the bottom. You can see the one on the top good. But what this is saying is that bird spends 95% of its time within this weird looking blue blob. Or, for this bird, within that brown blob. So that's the first thing. So we say, okay, so this bird lives within that blobby area. And then we can get lots of different type of data, like environmental data. So just as an example, like this, so these are the points for where the bird expands. But then we can get this background data, which in this case, this is elevation. I didn't put up any other examples, but so we have for example, what I'm working with right now is elevation, how rugged the area is, the human population density, roads and like proximity to roads, power lines and proximity to power lines, all these different things that we think like might affect vultures and how and where they live. Yeah. Oh, okay. And then we can try to contrast within this area, within this blue blob. We can say like the bird was here. Why was it there and not here, right? And we do that for all these different points, and we can figure out how they're selecting that they like to be close to power lines or they like to be close to people. And we can do that for all those different environmental variables. We can learn like how the bird selects for habitat. Does that make sense? Kind of. Yeah. That's all I have for Egyptian vultures right now. Does anybody have any questions on Egyptian vulture stuff? No.
When you talked about your assumption that they are going high, about the speed with which they fly, and they are like gliding down with acceleration. You told also that you get information of their location every minute. So can't you check on with distance per I don't know, hour or something?
Yeah, totally. So the stat I gave that they had covered 109 kilometers per hour as a max over a sustained period of time. So that was based on like calculating how fast they traveled between successive points. But I could like dive into that in more detail, right? And figure out like how much ground they're covering as they're gaining elevation versus as they're losing it. And I think that's really important and interesting, especially on migration, because migration is a really like trying time. It's a difficult time for birds. And so looking at how they travel and how they travel so fast is really interesting. And that's something that I will be working on as soon as I get back to the university. So I'll be working on that stuff this summer and fall. But great question. Any other questions about Egyptian vultures? And then I'll show you some pictures of buzzards. Okay.
I have one question.
Yeah.
Here you are doing the habitat modeling?
Yeah. So this will be like...
I understand you correctly. So just using some environmental variables and some humans and disturbance and so on to just put into the model and to see the priority areas for them.
Yeah, exactly. So that's the idea, right? So that we can say the idea is to learn from these individual birds about what we would think that the population of birds. So like, what would all the Egyptian vultures in the Caucasus like? So if we figure out what these 16 birds do, we might have a better guess about, if we want to conserve the Egyptian vulture, we might have a better guess about saying, okay, well this is what these 16 birds really liked. So let's try to work in those areas, this certain elevation, this, proximity to people, to develop like a better conservation strategy.